Our journey begins with a simple yet profound human impulse: curiosity. From the earliest days, we have looked up at the night sky and wondered, why do stars shine? What secrets do they hold, twinkling so far away? This urge to question, to seek answers beyond what is immediately visible, is woven into the fabric of our species. Why does an apple fall? What invisible force pulls it to the ground? These questions, simple yet profound, have inspired generations of thinkers to look deeper into the workings of nature. This relentless questioning is the engine of science. It drives us to experiment, to observe, and to challenge what we think we know. Physics is our quest to uncover the universe's fundamental rules. It's the language we use to describe everything from the tiniest particles to the vastness of space itself. It's not just facts and equations, it's a human adventure, a saga of discovery that stretches across continents and centuries, uniting people in the pursuit of knowledge. We built tools to see the unseen and imagined realities that challenged what we knew. From microscopes to particle accelerators, our inventions have opened new windows into the universe. The goal? To find the principles connecting a falling apple to the orbiting moon, to reveal the hidden threads that tie together the everyday and the cosmic. This search for cosmic order empowers us, letting us predict and harness nature's forces. It's how we learn to generate electricity, launch satellites, and explore the stars. For centuries, we saw the universe as a great machine. Planets moving in predictable paths, light traveling in straight lines, everything governed by clear, unchanging laws. Newton's physics gave us a clockwork cosmos, where knowing an object's position and speed meant predicting its future. The universe seemed orderly, logical, and almost comforting in its predictability. This classical view was comforting and matched our everyday experience. It made sense of the world we could see and touch. But as our tools improved, we looked deeper, into the heart of matter, smaller than atoms, into realms no eye had ever seen. There, the familiar rules broke down. Experiments revealed results that defied logic and expectation. The cosmic machine was no longer clockwork, but something wilder and more mysterious. The universe became a place of uncertainty, where chance and probability ruled. We needed a new kind of physics, a new story to explain the strange and wonderful things we were discovering. This is the story of the quantum world, a realm where particles can be waves, and where reality itself seems to blur and shift. A reality that defies common sense at every turn, challenging our deepest assumptions about how the universe works. Welcome to the quantum revolution, a new era of science where the impossible becomes possible, and the unknown beckons us forward. Let's begin our journey into the unknown, where every answer leads to new questions, and the adventure of discovery never ends. What is quantum physics? It's a question that has fascinated scientists and thinkers for over a century, and its answers have revolutionized our understanding of the universe. At its core, quantum physics is the discovery that, at the tiniest scales imaginable, energy and matter don't flow smoothly, but instead come in tiny, indivisible packets, quanta. This means the universe, at its most fundamental level, is built from discrete building blocks, not continuous waves. Imagine a staircase, not a ramp. You can only stand on one step or another, never in between. This simple analogy helps us grasp how energy levels work in the quantum world. This radical idea completely changed our understanding of reality, forcing us to rethink the very fabric of existence. At the subatomic level, things don't change gradually. Instead, particles make sudden, unpredictable leaps from one state to another. No smooth transitions, just abrupt jumps. Electrons in atoms, for example, exist at specific energy levels, like books neatly arranged on a shelf. They can't rest between shelves, only on one or another. To move up or down, electrons must absorb or release a precise quantum of energy, no more, no less. This is what gives rise to the unique colors of light emitted by different elements. This quantization is what defines the quantum world, a realm of sudden jumps, not smooth flows, where the rules are unlike anything we experience in daily life. Here, electrons, photons, and even quarks follow bizarre rules that classical physics simply can't explain. Their behavior is governed by probabilities, not certainties. Quantum mechanics unlocked the secrets hidden inside the atom, revealing a world stranger than anyone had imagined. In this realm, particles can exist in multiple places at once, tunnel through barriers that should be impenetrable, and even change their behavior simply by being observed. This isn't science fiction. It's a reality confirmed by countless experiments, and it continues to surprise even the experts. Quantum physics is our passport to a world that challenges the limits of imagination. opening doors to new technologies and deeper mysteries. It's the foundation of our modern understanding of nature, underlying everything from lasers to computers to the very chemistry of life. So, let's take our first step into the quantum realm and see just how strange and wonderful it truly gets. One of quantum physics' greatest mysteries is wave-particle duality, a concept that has puzzled scientists for over a century and continues to challenge our understanding of reality. For centuries, we thought things were either particles, tiny solid objects with definite positions, or waves, spread out disturbances that ripple through space, like sound or water waves. But then, experiments revealed something astonishing. Light, which we long believed to be a wave, sometimes behaves like a particle, showing up as tiny packets of energy in certain experiments. These particles of light are called photons. They can knock electrons off metal surfaces, as if they were tiny billiard balls, not waves. Even stranger, electrons, once thought to be the ultimate example of a particle, can behave like waves, spreading out and interfering with themselves. Fire electrons at a double slit, and you get an interference pattern, a wave signature, as if each electron travels through both slits at once and interferes with itself. How can something be both a particle and a wave? This question lies at the heart of quantum mechanics, and it defies our everyday intuition. The answer: a quantum object exists as a probability wave, a mathematical description of all the places it could possibly be at once until we look. Only when we measure it does the wave collapse, and the object chooses a definite spot. Our observation changes its nature, forcing it to pick a single outcome from many possibilities. Imagine a cloud of smoke, spread out, uncertain, filling the room. That's like a quantum object before we observe it. Grab a particle and you force it into one place, just as observation forces a quantum object to reveal a single position. Quantum objects are like this, existing as a cloud of possibilities, never just one thing, until observed. This dual nature is a fundamental truth of the quantum world, woven into the fabric of reality itself. It's not just weird, it's how reality works at its deepest level, and it continues to surprise even the experts. The act of looking shapes what we see, blurring the line between observer and observed. The universe is stranger than we ever imagined, filled with paradoxes and mysteries that challenge our understanding. And this is just the beginning. The journey into quantum reality is only getting started. Let's dive deeper and see what other surprises await. The wave-like nature of particles leads to the Heisenberg uncertainty principle. This isn't about faulty equipment, it's a built-in property of the universe. Heisenberg showed we can't precisely know both a particle's position and momentum at the same time. The more you know one, the less you know the other. Imagine measuring an electron's position. To see it, you bounce a photon off it, but that changes its momentum. It's like trying to pinpoint a ripple in a pond, spread out and uncertain. If you localize it, you lose track of its momentum. This is the trade-off at the heart of quantum mechanics. The uncertainty principle shatters the dream of a perfectly predictable universe. In classical physics, perfect knowledge meant perfect prediction. Quantum mechanics says there's always a fundamental fuzziness. The universe is a place of probabilities, not certainties. This was revolutionary and unsettling. But every experiment confirms it. Reality is inherently uncertain at its core, and that uncertainty shapes everything. Quantum mechanics has another surprise entanglement, what Einstein called spooky action at a distance. When two particles become entangled, they form a single system, no matter how far apart they are. What happens to one instantly affects the other, even across galaxies. Unlike a pair of gloves in boxes, entangled particles don't have definite states until measured. Each is in a superposition, both possibilities at once. Measure one, and the other state is instantly set, no matter the distance. This connection doesn't allow faster-than-light communication. The outcome is random, but it reveals a deep interconnectedness in the universe. Einstein was troubled, but experiments confirm it's real. Entanglement is a fundamental feature of reality. The universe is more intertwined than we ever imagined. Quantum physics challenges our ideas of space and separation. Reality is stranger and more connected than we thought. Quantum physics is a human story, built by brilliant minds confronting the unimaginable. Max Planck introduced quanta to solve a problem, laying the foundation. Einstein showed light was made of photons, winning the Nobel Prize for it, though he later doubted quantum randomness. Niels Bohr applied quantum ideas to atoms, embracing the weirdness and debating Einstein for years. Heisenberg, Schrödinger, Dirac, and others expanded the theory, each adding a crucial piece. Their courage and imagination built the most successful scientific theory in history. They changed our world and our understanding of reality forever. Quantum mechanics isn't just theory, it's the foundation of modern technology. Your computer or phone relies on transistors, which work because of quantum behavior in materials. Lasers, from barcode scanners to the internet, exist thanks to quantum principles. Even seeing color or the sun's energy depends on quantum effects. Medical imaging like MRI uses quantum spin. GPS satellites rely on atomic clocks, precise because of quantum leaps. The quantum world powers our civilization. Every day, you benefit from its strange rules. Quantum physics is everywhere, even if you can't see it. We're entering a new era, the second quantum revolution. Now, we're learning to control individual quantum objects, atoms, electrons, photons. Quantum computers use qubits, which can be 0, 1, or both at once. Linked by entanglement, they can solve problems classical computers can't touch. Quantum sensors could detect tiny gravitational fields, revealing hidden structures. Quantum communication promises perfectly secure channels. These technologies are young and challenging to build, but progress is rapid and exciting. We're pioneers, like the early days of classical computing. The quantum future is coming, and it could transform everything. The possibilities are just beginning. Our quantum journey ends where it began, with curiosity. Quantum physics teaches humility. Reality is stranger and more wonderful than we imagined. Deep mysteries remain, like how measurement collapses the wave function, or how to unite quantum mechanics with gravity. These are invitations to explore further. The quest for knowledge connects us to the cosmos and inspires innovation. The same curiosity that led to quantum mechanics will solve tomorrow's challenges. The quantum realm is part of us, and the adventure continues. The greatest discoveries may still lie ahead, waiting on the endless frontier.